I'm going to see if this is recording. It might just get the audio. Guys, this is lab. You ready? Lab 1. By the way, lab quizzes will just include things we did in the lab. I won't have from lab anything on your lecture quiz. You get what I'm saying? So things we do in lab, you don't have to study the lecture quizzes for those, just what we did in lecture. Right? This lab is separate. Use a lot of words to say that. But anyway, all right, so you already, lab 1 is measurements in science. And, you know, in science, in measurements for other things, sometimes you can be close to, and that's all okay. But measurements in science, you have to be exact. Is that right? So, so what I want to do with this particular lab is to give you guys some basics. How many of you feel really good about metric conversions? How many of you feel great about metric conversions? Now, come on, don't be modest. Really? Yeah, really. Okay, then. All right. So here's what I'm going to do today in a pretty short period of time, because it's all it's going to take if y'all are paying attention, if you're attentive. I'm going to talk to you about measurements in science, and I think I don't need to convince you that things have to be exact. Did anybody see Hidden Figures? Mm-hmm. Okay. Really? Would you have gotten on that ship? No, that spaceship, not with those kind of calculations that were needed, right? But anyway, measurements in science are important, and you all know that every single day, I don't know the exact number, but too many, drug dosage errors are happening. And I have nurses tell me a lot, and I've heard students tell me that other nurses have told them, just get through your drug dosage, just get through that part of the T-stats, just get through that, because you don't have to do any of that. The pharmacy sends the thing. So the doctor orders the pharmacy. Guess who's the executioner? The nurses. And I'm going to tell you all something that you might not believe, but this is really true. With drug dosage, it's 3rd grade math. 3rd grade. You know what the problem is? You haven't had that math since when? 3rd grade. Yes. So I want you to get rid of your anxiety and get rid of your fear when you hear the term math and think, oh, no, I can't do math. I can't do math. That's my weakness. I want you to just get rid of that right now and pretend like we're starting with a fresh plate, and you guys are going to kind of just trust me, flying at this point, but trust me, and let's see how it goes, okay? Let's see how it goes. Before we talk about, like, metric conversion and drug dosage and whatever, I have to let you know that it's the metric system that you have to use to have any hope of being exact. Our system, our American system, is not exact at all. And I could give you all a little quiz right now, our system, and none of you, I've got some bright people in here, because I already know some of you, really bright people, brighter than I am, but you'd fail that. There's not a single person in here who would pass it. So Americans are refusing to learn the metric system, and at the same time don't know their own. And I don't blame them for not wanting to know our own, because it's ridiculous. It's a ridiculous system. But anyway, so just to give you some incentive to maybe pay attention to this for a second. Let me ask y'all something. If I were to say that you had this many cookies, how many cookies do you have? You have 500, you know that for sure? That's how many I just wrote, 500. Okay, so if I were to tell you you had this much of a pizza, how much do you have? You know that? So because this is 1, and this is what? 5 tenths, which is a half. Did you know that? Y'all already know the metric system. Relax. Everybody sit back and relax. If you knew this, you already know the metric system. Now, I'm going to prove to you that that's right. And I'm going to prove to you that converting with the metric system is just 3 steps. No cross multiplying, no doing any of that, just 3 steps. Okay? So let me give you some basics here first, though. Y'all have all heard of scientific notation, have you not? Mm-hmm. Scientific notation, because we really need that in science, because in science, sometimes we're dealing with huge numbers. And sometimes we're dealing with tiny numbers. So sometimes, and by the way, you never get a number in anything unless you're given a unit that you're talking about. You're never going to go to somebody and say, I have 17 Because they would say what? You have 17,000 what? You know, right? So you don't ever use a number unless you're given a unit with it. Does that make sense? Okay. But for right now, I just want to talk to you about really big numbers that can happen in science and really little numbers that can happen in science. And so I'm going to give you an example of a really big number in science. And I'm just making it up right here, but 2, 3, 4, 5, 6, 7, 8, 9, 10. And could I actually have about 40 zeros in some units in science when we're talking about distances and we're talking things? I mean, scientific numbers are crazy big, right? Sometimes they can be. So here's the thing. I could say, okay, everybody tell me what that number is. Like, tell me what it is. And you'd be thinking, oh my, this is like a million. So you'd have to be looking at that. And it would be a pain in the butt, right? Especially, you wouldn't even have a name for it if there were 40 more zeros, would you? So scientific notation is taking really big and really little numbers and just writing them in an easier way. Is there anything about converting or changing the number in scientific notation? You better not, because in science you need to be exact. Scientific notation is simply taking a number that would look like this and just writing it easier so that you wouldn't have to say some crazy number, you know. So writing it easier, and it can help you to not make mistakes. So let me give you a couple of steps for always doing scientific notation right. You ready? This is scientific notation. After I give you these steps for scientific notation and then conversion in the metric system, I'm going to give you a practice. This is just for you to practice. Anybody who has any issues with practicing before we come back in here and have, it's fine if you have issues, we'll clear them up Thursday. Is everybody relaxed? Right? Everybody's good, right? It's not a big deal. All right, look. It would be a big deal if you're trying to put a man somewhere in space, but it's not, though. So, okay, so here's the steps. And I don't care if it's a big number or if it's a really little number, the steps are always the same. In scientific notation, when you're asked to express something easier, you do 3 steps. First, you locate your first real number, that you get to. What's the first, when you read numbers left to right, like you read, what's the first real number you get to? 4. Okay, you locate, and this is part of the first step. You locate the first real number, and you put an imaginary decimal. I'm actually going to write that in a different color. You put an imaginary decimal behind the first real number. Was that an easy first step? Was that an easy first step? All right, that's always your first step. Your second step is always then to locate the real decimal in your number. And if a decimal's not given, you know it's a whole number. So where's the decimal always understood to be? Okay, so man, that was kind of easy, wasn't it? All right, so far the steps aren't too bad. So the next and final thing, and you guys, this is really no harder than this. The next thing is to count the spaces between your imaginary and your real decimal. Count the spaces between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if I were really doing this for serious, I would do it a couple of times, make sure I had it right. Right? Please don't start with 1, because that's not a spacing. It's 1, 2, 3, 4. Doesn't matter if you go left or right, just count the spaces between. And did we say that was 11? Mm-hmm. That means there are 11 decimal spaces. Deci means 10, doesn't it? Mm-hmm. And now, guys, you're finished because your imaginary decimal becomes your what? Your real decimal, and any real numbers must be written that are up there. Are you good? So did I change that number? No. I didn't change it at all. Which one is the easiest one to write, especially if I had 40 more zeros? If I had 40 more zeros, I mean, how crazy is that? It would be a 51. So is this easier to write than that one? And if I were doing a research thing, and this is the number that I had to, whatever units it was, teardrops and wounds, whatever, wouldn't that be good? Okay. So if whatever units I had, and I had to keep writing that, I wouldn't want to write all those zeros out every time. It could lead to error. This is so much easier, isn't it, to write it that way? That's all scientific notation is. Does it work for little numbers? Like if you don't even have one of something, if you don't even have one cookie, you don't even have a 1/10 of a cookie, right? You don't even have 100th of a cookie, a 1,000th, a 10,000th, 100th. Man, you're about to get down to a piece of flour right here, okay? All right, look, so you just have something that is really tiny. Now you would have to have a unit because nobody would say that number without a unit. Let's say cookie. All right. So, but anyway, it's not even one, is it? Can we express this in scientific notation that would just make it a little bit easier? Cody, what's the first step? What's the first step? What is the first real number you get to? And what were you supposed to do behind that? Is that fair? What was the second step? Locate your real decimal and then count the spaces between. Is it 10? Somebody counted with me, right? It was 10. So those spaces between is our exponent number, and since these are decimal spaces, deci to the power of 10, is that right? Is that right? So 10 to 10. And then our imaginary decimal becomes our what? It becomes our real decimal, so we can either write it like that or it's understood that it would be right here. Am I finished yet? Why am I not finished? Because this isn't even one of something. It's not even one of something, so I have to remember to put the negative in those decimal spaces. I have had students miss every one of these because they say they were taught, if I move the decimal to the left, I had to make it a negative. If I moved it to the right, and they lose their mind. Look, if I have this many puppies, are these whole puppies? This is a positive number. If I have, oh, that would be terrible to have a half a puppy. But I don't even have one, so it's a negative. You know, they lose their minds. They're like, no, but I remembered if I was counting the net to the left, I had to do, and it's like they forget to just look at your number. If it's not a one, if it's not a whole number, it's not even one of something, what must you put? Now, if you didn't put the negative, you change the number because now you've got this with 10 zeros as a whole. So you can't change the number in scientific notation. It's just a way to write a number easier, right? Now look, do I have any questions about that? All right, here's what I want you to do, just for fun. I want you, on your papers, you don't even have to say it out loud, I want you to, now, we could say 1,000 pretty easily, couldn't we? We could say 1,000 and we could write this in our paper, you know, many times and probably not mess up, probably. But anyway, just for fun, I want you to write this in scientific notation. And just for fun, I want you to write this in scientific notation. So you got two things. You just sit there at your desk using the steps if you have to. And if you don't have to, you already know how to do this, and that's fine. But anyway, do that. And when you're finished, just put your pen down. Thank you. So, okay. So y'all. Because you kind of have to get this to go to the next thing. Okay. Okay, I think most people are finished, but if you haven't finished, don't worry because, you know, whatever, we'll do it together. Do it with us. So in this one, you located the first real number to be this 1 here, and you put an imaginary decimal behind it. Then you located the real decimal, which was understood to be here as a whole number. You counted the spaces between, which became your exponent, decimal spaces, to 10. And then you could have written this if you needed to, or you know anything times 1 is itself, or you could have just written it like that. That's all. They're all right. Did y'all get that? You got that? And that is that in your notes right now? Because I want to refer back to that in a minute. Is that good? Everybody's good. Nobody's too. That's not too tricky. Okay. So in this one, you did the same thing. You located the first real number. You put an imaginary decimal behind it. Then you located your real decimal, which was given in this case. and then you counted the spaces between it, and that became your exponent number, and again, to this, but you had to put a what? Because you looked at your number, you weren't thinking left and right, you actually looked at your number, and you know it's not even what? So you had to put the negative, and is that correct? Yeah, that's correct, or you could just write that, and that's correct too, right? All right, is it regular? All right, so that's just scientific notation. Are you changing the number? No. Are you converting it? You're just writing it in an easier way. Is that right? And it's easy because it's decimal spaces, and you all already know decimal spaces, so you're good. Now I'm going to give you a second, because y'all will have a few of those to do on the first line quiz. You'll have a few of those to do. I'm not going to be trying to trick you. Just use the steps, and you'll be good. Okay? The next thing you're going to have to do is conversion in the metric system. Relax. Everybody relax, right? It's going to be fun. But here's what I want to tell you about. You already know how to do this. You already know that if you had 1,000 of something, what did you say that exponent number was? What did you say that was? What's the exponent to write this in scientific notation? 3. You said that's a 3? Did you say that? Really? Is that what everybody got? Okay. And then you all know that I told you you are never going to use a number unless you're given a what? Unit. So that unit might be cookies. It might be Kool-Aid. I don't know what it might be. It might be tears. It might be seconds. It might be minutes. But in the metric system, if it has to do with mass or weight, it's going to be gram. That's what the unit's going to be. In the metric system, if it's distance, it's going to be meter. And in the metric system, if it's volume, it's going to be liter. Is that fair enough? So the way in the metric system, gram is abbreviated with a little g. The meter is a little m, and liter is a lowercase l. Fair? So this is actually referred to as your standard. And that means you're going to be given a standard unit. You're going to have to be, because nobody says, I have 6. It's 6 what? What? Right? You all know that if you are this many away from a standard, what do y'all call that? How many is that? 10? 10. And this is what? 100. And this was a what? So this scientific notation, the exponent would be 2 up here, and this one will be 1. Because that's how far you're from your where to have one of them. To have one of them, you're that many decimal spaces from that. Is that fair? Did you make anything up? Or do y'all already know that, right? All right. Okay. Now, if we went this way and we were at this, or this, or this. Okay, we'll talk about that in a second. I want you to know that in the metric system, and you do kind of have to know this, these little, each decimal space has a prefix. A prefix is not a standard unit. It's not a standard unit. So the prefix for 1,000 is kilo. Kilo. The prefix for 10 is deca. You don't have to write that one, don't, because we don't use it in science. This is hecta. We don't use that either, so don't even write it. But you know that space is there, because y'all know if I told you you had this many puppies, how many do you have? 250. That's 100, right? So that's hecta. This is deci, which is what did y'all know deci is? It's a what? A 10, but we don't use that prefix either. But nobody's going to come up to you and say, I have 6 decas. Or I have, well, if they said, the only thing that's used as a prefix for real things are drug dealers. Okay, and we know how smart they are, right? Right? So you don't use prefixes, though, unless you're given the standard. So you have you're going to have a kilogram, right? Or it's going to be a kilometer, or right? Or a kiloliter, right? So you're going to be given the standard for sure. This is deci, and that's not used either, but it's certainly a decimal place over. It's 1 decimal place over. It's actually a -1. Would y'all have known it was -1 away from your standard? How would you have known that? From the what? Scientific notation. Wouldn't you have? Let me tell you what is used as a prefix quite often is something called centi. And this is, guess what this exponent is? -2. Let me tell you what else is used frequently, and that's a milli. A milli is going to be 3 spaces from the standard. Am I saying anything too crazy yet? Or would you all have known that this was 1,000th, right? 1,000th. You would have known that. If I had a little 4 right here, it would have been 4,000. I'm a tired talent, so I say it funny. But are you with me? All right. If I go 3 more spaces over, there is another prefix that we often use in medicine. Sometimes it looks like that. Sometimes we do MC. But what it stands for is micron. It's a prefix. Do you ever use it by itself? No. No, you would have to say a micron, a microgram, right? Or micrometer, right? You wouldn't use it by itself because it's simply a prefix, isn't it? And if we kept going, we could even get to something called a nano. Have y'all ever heard of nanotechnology? This is 9 decimal spaces from having 1. Are you good with that? Of your standard. So this is like, this would be like this. 1, 2, 3, 4, 5, 6, 7. I'm running little because I'm running out of space. Wow, that's tiny, isn't it? Of whatever you're talking about. Can you imagine having only this of a cookie? Right, sad. All right, you tell me. All right, so this is 1,000, right? A million, right? And a billion. These are tiny. Where did I get these numbers that I have up here? Where did I get these numbers? They're the what? Which, did y'all think that was made up or anything? No, did y'all knew how we got to the scientific notation exponent, didn't you? You just counted decimals places, didn't you? All right. So if this doesn't look just crazy to you, and by the way, we don't use deci, so I'm just going to take it out right now. We don't use deca, we don't use hecto. But anyway, they're there. Their spaces are there. But anyway, I could talk to you about our system. Our system for grams, we use what? Ounces. What else do we use? Pounds. Tons, right? We use those. So if I were to ask you how many ounces are in 17.7 pounds, it would take you a bit, and you would have a stupid looking number. Okay. Because how many ounces are in a pound? Where did that number come from? Who decided that? 16. Why are you coming to remember 16 and 2,000 pounds at a time? I mean, I could give y'all a test, you wouldn't pass it. In our system, distance, meters, what do we have? We have inches. We have what? Feet, yards, miles. How many yards are in 1.7 miles?
No idea.
Huh?
No idea.
In our system, we have ounces, teaspoons, tablespoons, pints, cups, pints, quarts, gallons. Do y'all want me to test you on that? Are there weird kinds of numbers you have to remember for them? And even if I were to ask you to convert something, you would end up with a crazy remainder number. You get that? And the chance for error in our system is just off the charts. If you don't think I made anything up, like 3 feet in a yard, 16 ounces in a, those kind of crazy numbers. If you don't think I made anything up on here, y'all just understood decimal points, which you all will prove that you did at the beginning. And you understand that these are prefixes, that the scientific notation exponent tells you how far you are from here. So in a kilo, how far are you from the standard? How many spaces? 3 decimals always, or just sometimes? Always. So this is a kilo. If I were to tell you that a milli is how many spaces from the standard? -3 from the standard. And centis, -2 from the standard. How many are they from each other? 1. They're 1 space from each other. If a micron is 6 from the standard, how many is it from the milli? 3. How many is a micron from a centi?
4.
How many is a centi from a kilo? 5. You get that? If y'all know this, you can do metric conversions from all day with 3 steps. You ready? You ready? Let's see if that works. If I'm telling the truth. All right. I am on, and this is like a true story. I am on 125 micrograms of Synthroid. Because my thyroid gland, I decided to try to destroy it when I was 30. Not intentionally, it was an autoimmune disease. Okay, so whatever. But a lot of times, pharmacies won't have the drug, Synthroid, in micrograms, but they have them in milligrams. So I'm going to have to get to what? Milligrams. Because I'm going to need to know what to order in milligrams. All right, now look. Y'all wrote that down. Now I want you to put your pencils down and just listen to 3 steps. Because whenever you're doing, and a lot of drug dosage problems, the first thing you have to do is metric conversion. And then the rest of the problem is dividing and multiplying or just adding. It's simple. It's so simple. But this is simple too. I want to show you. If you understand these numbers and what they relate to the standard is telling you that tells you how far they are from each other. If you know that, you can do 3 steps. You never even care about the number until the last step. The first step is to see where you are on the scale. In this case, where am I? I'm at -6 microns. That's always the first step. Where am I on the scale? Now, I'm going to let you write this down in a minute. Let's just see if it really works. So y'all said I'm here. The next step is to see where you've been asked to go. Where have you been asked to go? To milli. And then the final thing, this is the last thing, you ask yourself, is that to the left or to the right? And how many? It's to the left, how many?
3.
Now I look at my number, don't we now? I know if the decimal is not given, it's meant to be here. And are you telling me I just have to move it to the left 3? Are you sure?
Yes.
Because you know I'm sweating. I'm sweating. Are you sure that I just have to move this to the left 3? And that's the answer? All day. All day, that's the answer. Right? Now, why did I put a 0 in front of that decimal? The reason I did that is if I wrote it like this as my answer, or if you saw a physician writing a script for Synthroid like this, could you have missed that decimal?
Yes.
But if you have a decimal in front of real numbers, you had better have a 0 here so somebody's looking for it. Nobody writes 125 like that. Do they? Nobody. So you would be looking for that. Does that make sense? So that's just good bookkeeping. Let's see if those 3 steps really do work. Are you kidding me? Let's see. Let's see if I had, let's do this one. Did y'all write that one down just for practice? Did you? I have a hard time coming up with numbers. Let's say, and by the way, do I have to use different, like I do in our system, do I have to use different things depending on what unit I'm talking about? I could be talking about teardrops or raindrops, and I would still be using these same 3 steps. Understanding the prefixes and what their exponent numbers are, telling us that's how far they are from 1 of the standard, and using this. Suppose I had kilometers and I wanted to know how many meters that was. Now, by the way, the hardest thing about metric conversion is that we have 2 little m's in our thing. But if you're only given 1, what must it have been? It's got to be the standard, because you don't get a unit with a prefix without the standard. So we got to be talking about meters. So what's our first step? We never look at our number until the very end. What's our first step? Where am I? Kilos. Where have I been asked to go?
Standards.
To the standard. And how many spaces is that in which direction?
3.
3 to the right. Are you sure? And so now I just look at my number. If this decimal's here, I move it 3 to the right. And are you saying this is the answer? Yes. Metric conversion is simply moving a decimal. You never change the whole numbers. In our system, you would be having to remember weird things. Y'all tell me how many tablespoons are in 2.4 gallons. Tell me right now. What? Yeah. Does anybody know? If you do, I'm not trusting you. You know, but really, how many tablespoons? Let's make it easier. How many are in a cup? Do you know? 16. Is it 16? Yeah. Okay, so we could figure it out. But we would end up having, and if we were dividing, if I was saying it's just ridiculous. This one, 3 steps. See where you are. See where you've been asked to go. Ask yourself, is that to the right or the left? And then just do it. Right? You want a few more? Want a couple more? Or are y'all good? You want the practice ones? Are y'all good? You want a couple more?
Good.
Okay. So see where you are. See where you've been asked to go. Make sure you understand which direction that was and how many spaces there are. And then just move the decimal. Right? Here's practice for you. This will be an absolute, exactly like your first lab quiz. So if you all do this example, the way, you use this practice right and feel good about it, then your first lab quiz should be on 100, right? And don't worry, you get to keep these. You don't turn these into me. But what we do is we're going to go over them at the beginning of lab Thursday. And if you had trouble with them, that's the time to figure it out. Because the lab quiz on this will be the next week. Right? Yeah. Does anybody want to stay for a few extra ones? Practice before you do these. You got one. I want to tell you all before you leave, I wanted to give you one example of the first drug dosage problem on the our RN first semester. You ready for it? You ready for this, guys? It's a word problem because most of them are. People require word problems. People are word problems. That could be the title of the book. All right, look, so, so this, I want to try to remember how it is, and it won't be verbatim, but it's something like this. And it's a paragraph, long. It says patient comes in with so-and-so, and it gives some horrific disease. And been diagnosed with this, and then they put on like this medication, and the medication's name's huge. And you just ignore all of that. You just look for the math problem. You ready? It says the doctor orders 1.5 grams of a particular drug, and the pharmacy has the drug in 1,500 milligram tablets. Right? So how many tablets of this big name drug is this patient going to be getting? Right? So what you see is the word problem is that the prescription was for this, grams, but you've got to get to what? Milligrams. You've got to get to milligrams first. Can you use this to do that? Yeah. Where are you? Where you've been asked to go? Right. To milli, which is to the right 3 times. Let's go ahead and do it. 1, 2, 3. 1,500 milligrams is what the patient's really prescribed. Is that right? And the pharmacy has it in 500 milligram tablets. How many tablets are you going to get? 3. That's drug dosage. Are you good with this? Okay. But the scariest thing are the word problems, and the scariest thing is the metric conversion and doing it right. If y'all know this, will you know how to do metric conversion? Will you? Okay, it takes practice. Math, if you're not using math, we tend to lose it, right? So you do have to practice. Do I have any questions? If you have just one M there, where must you be? Standard. Because if it's milli, it's going to be little mg little little ml, right? Another weird thing, not really weird, it's just apothecary equivalencies, but sometimes y'all will see cc's, but they are actually just equal to mLs. They're equal to mLs. So if something required a 250 cc, it really required 250 what? mLs. Now are you on your chart? Now are you on your thing? Yeah. Okay. All right, guys. Everybody good? Y'all are going to put a study guide up for me, aren't you? From today's lecture. Do y'all think you have enough notes to give 10 facts?
Yeah.
Hey guys, I'm going to remind you from today's lecture, lots of it was just definitions, right? Definitions, psychology, histology, palpation, occupation, gross anatomy. A lot of it was done, but anything we talked about wasn't fair to ask about. I need your contracts if you decide to stay in the class. I guess you are. You want to come back after break. Keep these because I'm going to get you all to do something with these Thursday. So please keep these, okay? At the end of class, and we'll get you to do something with these. I need your contracts though, and you'll see that I give you credit for printing those in. You can put these contracts right here. Yeah, I just need the contract. I don't need your whole syllabus back. I just want your contract.